According to the National Electrical Code, it is not permissible to have a multi-wire branch circuit with one circuit in the emergency panel and the other in the normal panel. National Electrical Code Article 700.32b2 requires that all conductors of a multi-wire branch circuit must be grouped together in the same panel board or switchboard. This is to prevent an unbalanced load between the phases, which could result in overheating and potential fire hazards. Therefore, if you want to have the kitchen circuit and the emergency panel, you must also move the washer circuit to the same panel. You can accomplish this by installing a separate circuit breaker for the washer in the emergency panel. Additionally, ensure that the emergency panel is properly sized and configured to handle the electrical load of both the kitchen and washer circuits. Let's delve deeper into the concepts and requirements involved. Firstly, we should define what a multi-wire branch circuit is. A multi-wire branch circuit is a circuit that consists of two or more ungrounded conductors having a voltage between them, and a grounded conductor having equal voltage between it and each ungrounded conductor of the circuit, and which is connected to the neutral or grounded conductor of the system. Multi-wire branch circuits are commonly used in residential and commercial electrical systems to provide multiple 120-volt circuits while sharing a single neutral conductor. This can save on wiring costs and reduce the number of circuits needed in a panel board. However, multi-wire branch circuits must be installed and used correctly to avoid electrical hazards. Secondly, it's important to understand the requirements outlined in National Electrical Code Article 700.32b2. This section specifically addresses emergency systems and the grouping of conductors. The requirement that all conductors of a multi-wire branch circuit must be grouped together in the same panel board or switchboard is crucial for several reasons. 1. It ensures that the neutral conductor is not overloaded. In a multi-wire branch circuit, the neutral conductor carries the unbalanced load between the ungrounded conductors. If one circuit is heavily loaded and the other is lightly loaded, the neutral conductor will carry the difference in current. If the neutral conductor is not properly sized or if it is disconnected, it can become overloaded and overheat, which could lead to a fire. 2. Grouping the conductors together helps to prevent voltage imbalances. When the loads on a multi-wire branch circuit are not balanced, the voltage on each ungrounded conductor can be different. This can cause equipment to malfunction or fail. 3. It simplifies troubleshooting. If there is a problem with a multi-wire branch circuit, it can be difficult to troubleshoot if the conductors are not grouped together. By keeping the conductors together, it is easier to identify the source of the problem and make repairs. Now let's consider the specific scenario presented: the kitchen circuit and the washer circuit sharing a neutral conductor. The kitchen circuit is intended to be connected to an emergency panel, while the washer circuit is to remain on the normal panel. This arrangement violates the National Electrical Code requirements for multi-wire branch circuits. The primary concern is the potential for an unbalanced load and overloading of the neutral conductor. If the kitchen circuit is powered by the emergency generator during a power outage and the washer circuit remains connected to the normal power supply, the neutral conductor will only carry the current from the kitchen circuit. This can cause the neutral conductor to become overloaded, especially if the kitchen circuit has a high current draw. Furthermore, if the neutral conductor becomes disconnected, the voltage on the kitchen circuit can rise to 240 volts, which could damage appliances and create a safety hazard. To comply with the National Electrical Code and ensure electrical safety, the washer circuit must also be moved to the emergency panel. This can be accomplished by installing a separate circuit breaker for the washer in the emergency panel. The circuit breaker should be sized appropriately for the washer's electrical load, and the wiring should be installed in accordance with the National Electrical Code requirements. Another consideration is the sizing and configuration of the emergency panel itself. The emergency panel must be sized to handle the electrical load of all the circuits that will be connected to it, including the kitchen and washer circuits. The panel should also be configured to provide adequate protection for each circuit, such as overcurrent protection and ground fault protection. It is essential to consult with a qualified electrician to determine the appropriate size and configuration of the emergency panel for your specific needs. Additionally, it's crucial to ensure that the emergency generator is properly sized to handle the increased load of the kitchen and washer circuits. The generator should have sufficient capacity to supply power to all the essential circuits during a power outage without being overloaded. Overloading the generator can damage the generator itself and potentially create a fire hazard. In summary, the National Electrical Code prohibits splitting a multi-wire branch circuit between an emergency panel and a normal panel. All conductors of a multi-wire branch circuit must be grouped together in the same panel board or switchboard to prevent unbalanced loads, overloaded neutral conductors, and other electrical hazards. To comply with the National Electrical Code and ensure electrical safety, the washer circuit must be moved to the emergency panel, and the emergency panel and generator must be properly sized and configured to handle the increased load. Moving the washer to the emergency panel is not just about code compliance, it's about ensuring the safety of the electrical system and the occupants of the home. Unbalanced loads and overloaded neutrals can lead to overheating, insulation damage, and ultimately, electrical fires. By adhering to the NEC guidelines, you are minimizing these risks. When adding the washer circuit to the emergency panel, consider the total load and the panel. Ensure that the generator is capable of handling the combined load of the kitchen and washer, along with any other essential circuits connected to the emergency panel. This prevents overloading the generator and ensures that all critical appliances and systems can operate during a power outage. It's also important to properly label the circuits in both the main and emergency panels. Clearly identify which circuits are connected to the emergency generator and which are not. This helps prevent confusion during a power outage and ensures that the homeowner can easily manage the electrical system. Grounding is another critical aspect of electrical safety. Ensure that both the main and emergency panels are properly grounded according to the NEC requirement. Proper grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. Regularly inspect the electrical panels and wiring for any signs of damage, such as frayed wires, loose connections, or corrosion. Address any issues promptly to prevent potential electrical problems. Consider installing surge protection devices at both the main and emergency panels to protect sensitive electronic equipment from voltage surges. Surge protectors can help prevent damage to appliances and electronics caused by lightning strikes or other electrical disturbances. Educate the homeowner about the proper use of the emergency generator and the electrical system. Explain how to switch between the main power and generator power, and emphasize the importance of not overloading the generator. Remind them to regularly test the generator to ensure it is in good working condition. When making any electrical modifications or repairs, always follow the NEC guidelines and local electrical codes. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Working with electricity can be dangerous, and it's essential to take all necessary precautions to prevent electrical shock or fire. Here's a summary of key takeaways. 1. Splitting a multi-wire branch circuit between normal and emergency panels is a violation of the National Electrical Code. 2. National Electrical Code Article 700.32b2 requires all conductors of a multi-wire branch circuit to be grouped together. 3. The washer circuit must be moved to the emergency panel to comply with the code. 4. The emergency panel and generator must be properly sized and configured to handle the increased load. 5. Always prioritize electrical safety and consult with a qualified electrician if needed. Let's elaborate on the potential consequences of ignoring these guidelines. Overloading the neutral conductor can lead to several problems. The neutral conductor is typically smaller than the hot conductors in a multi-wire branch circuit. If the neutral is overloaded, it can overheat, melting the insulation and potentially causing a fire. A damaged neutral conductor can also create a voltage imbalance where one leg of the circuit has a higher voltage than the other. This can damage sensitive electronic equipment connected to the circuit. An open neutral, where the neutral conductor is completely disconnected, is an even more dangerous situation. In this case, the voltage on the two legs of the circuit can become highly unbalanced, with one light potentially reaching 240 volts and the other dropping to zero. This can cause severe damage to appliances and create a significant electrical shock hazard. Voltage imbalances can also negatively impact the performance of electrical equipment. Motors may run hotter and less efficiently, leading to premature failure. Electronic devices may malfunction or display incorrect readings. Lights may flicker or burn out prematurely. To prevent these problems, it's essential to follow the NEC guidelines and ensure that multi-wire branch circuits are properly installed and maintained. This includes using the correct wire sizes, ensuring that all connections are tight, and regularly inspecting the wiring for any signs of damage. When working with emergency generators, it's crucial to understand the different types of generators available and their capabilities. Some generators are designed to automatically switch on when the power goes out, while others require manual starting. It's important to choose a generator that is appropriate for the specific needs of the home and the electrical system. Automatic standby generators are permanently installed and connected to the home's electrical system. They automatically detect a power outage and start up, providing power to the selected circuits. These generators are typically powered by natural gas or propane. Portable generators are smaller and can be moved around as needed. They are typically powered by gasoline or diesel fuel. Portable generators require manual starting and must be connected to the home's electrical system using a transfer switch. A transfer switch is a device that allows you to safely switch between the main power and generator power. It prevents backfeeding, where the generator power is sent back into the utility grid, which can be dangerous for utility workers. When connecting a portable generator to the home's electrical system, it's essential to use a properly sized transfer switch and to follow all safety precautions. Never plug the generator directly into a wall outlet, as this can create a dangerous backfeeding situation. Always run the generator outdoors in a well-ventilated area to prevent carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that can be deadly. Install carbon monoxide detectors in the home to provide an early warning of dangerous carbon monoxide levels. Regularly test the carbon monoxide detectors to ensure they are working properly. When sizing an emergency generator, it's important to consider the total wattage of all the appliances and devices that will be connected to the generator. Add up the wattage of all the lights, refrigerators, freezers, televisions, computers, and other essential devices. Choose a generator that has a wattage rating that is higher than the total wattage of all the connected devices. This will ensure that the generator can handle the load without being overloaded. It's also important to consider the starting wattage of some appliances, such as refrigerators and air conditioners. These appliances require a higher wattage to start up than they do to run continuously. Choose a generator that has a starting wattage rating that is high enough to handle the starting load of these appliances. Many generators have a surge wattage rating that indicates the maximum wattage they can provide for a short period of time. When selecting an emergency panel, it's important to choose a panel that is properly sized for the number of circuits that will be connected to it. The panel should have enough spaces for all the circuit breakers that will be needed. It's also important to choose a panel that is rated for the appropriate voltage and amperage. The panel should be installed in a location that is easily accessible and protected from the elements. The panel should be properly grounded according to the NEC requirements. When installing wiring for the emergency panel, it's important to use the correct wire sizes and types. The wire sizes should be appropriate for the amperage of the circuits that will be connected to them. The wire type should be suitable for the environment in which they will be installed. All wiring should be installed in accordance with the NEC requirements. It's also important to properly label all the circuits in the emergency panel. This will make it easier to identify which circuits are connected to the generator and which are not. Consider using different colored wires to distinguish between the emergency circuits and the normal circuits. Use a permanent marker or label maker to clearly label each circuit breaker in the panel. When working with electricity, always take the necessary safety precautions. Wear appropriate personal protective equipment, such as safety glasses and gloves. Turn off the power to the circuit before working on it. Use insulated tools. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Working with electricity can be dangerous, and it's essential to take all necessary precautions to prevent electrical shock or fire. By following these guidelines, you can ensure that your emergency panel and generator system is properly installed and safe to operate. This will provide peace of mind knowing that you will have power during a power outage.